so today we are going to take notes on the kinematic equations. Now remember, kinematics is the study of motion, describing how motion occurs, describing the motion. And really we've talked about two equations that we use. We said that there's the velocity, which we're defining as, and technically this is the average velocity, which we're defining as delta x over delta t. There's the average acceleration that we're defining as the change in velocity over the change in time. And that's really what we've got so far. Now today I'm going to teach you three new equations. Today we're just going to write them down and you're just going to accept them as being true. Next class I will derive them for you. I'm not sure if it'll be next class or a few more classes, but we'll eventually derive these. But today I just want you to write them down, and then we will practice using them. So the first equation we use is v equals v naught, so that's final velocity equals initial velocity plus acceleration times time. Now I give these equations names because I think it's fun. So I call this equation Old Faithful. And this other one, the next equation is x equals x naught plus v naught t plus 1/2 a t squared. This equation is a little bit harder to deal with because it's got a t and a t squared in it. So we could say like it's a little bit spicier of an equation. So for that reason, I like to call this equation the Big Chalupa. And we've got one other equation. V squared equals v naught squared plus 2 times a times quantity x minus x naught. And this equation is the equation you use. There's no time in this equation. So if you don't know the time in a problem, you use this equation. And for that reason, we call this equation ain't got no time. All right. So these are the three new kinematic equations. Again, I'll show you where they come from eventually. But for now, just accept that these are the equations. Now, I want to talk about how you use them. So here's the first question I wanted to try. So I've got a minivan starts at rest and then accelerates at a rate of 3 meters per second squared for 10 seconds. How far does the minivan travel in this time? Okay, so again, the first thing we need to do is we need to draw a picture. And I'm going to start requiring pictures when you do your homework in this unit. And the reason why is because, well, specifically I need to know what axis you're picking. I'll show you what I mean here. So here's my minivan. Starts at rest and it accelerates at a rate of 3 meters per second squared. Now remember, I draw my velocity vectors as a single arrow. I don't know what his velocity is. Well, I do know that his initial velocity is 0, I guess. And then, so I guess he's not moving initially. And then his final velocity when he gets here is, I don't know what that is, but I do know that he's going forward. So, and when I say an axis, what I mean is I want you to tell me where your origin is. So I'm going to draw a set of axes here, right? This is my x-axis and this is my y-axis. Because if I do this, I can say, where am I starting? I'm starting at the origin. Okay? Because you could also solve this problem. You could also put your origin here. But as the problems get more complicated, setting up what this origin is, or what this coordinate system is going to be important. Right? So I draw my velocity vectors as a single arrow, and I draw my acceleration vectors as a double arrow. So remember, acceleration is a vector, and if it's going positive 3 meters per second, that means I've got an acceleration vector going 3 meters per second squared forward. Okay? So that's my picture. Next step, remember, is the knowns and unknowns. So here's what I'm going to do. I'm going to say, I already said my v naught, my initial velocity is 0. Okay? My final velocity, remember v without something, I don't know it, but I also don't really need it, so I'm not even going to write that down. Okay? I know my acceleration is 3 meters per second squared. Is there anything else I know? I know it took 10 seconds, right? So I could say that my time my delta t, or my t, is 10 seconds. And then I'm going to say how far. So if the question is how far does a minivan travel, right? On my picture, that means I want to know what's my final x position, right? If I say that I started from an x naught of 0 meters. So these are my knowns and unknowns, right? You'll notice I did not put v as an unknown because I'm not asked for it, right? I only write down the things that I'm directly told or that I'm looking for. So I'm directly told acceleration time and that I start from rest. Acceleration time and I start from rest. And I'm looking for how far. So I'm looking for x. Okay. Now, I've got these 3 new equations. The nice thing about having done these knowns and unknowns is I know I'm looking for an equation that has a v naught, an a, a t, an x, and an x naught in it. And which equation has all those variables in it? You should see that it's big chalupa. So what I'm going to do is I'm going to go ahead and write down big chalupa. So x equals x naught plus v naught t plus 1/2 a t squared. So that's the equation. And then I can just plug in x equals 0 meters plus 0 meters per second times 10 seconds plus 1/2 times 3 meters per second squared times 10 seconds squared. Now you notice all my zeros cancel out, so I'm really just doing this last thing. So 1/2 times 3 times 10 squared is, if I'm right, I think it's 150 meters. And you'll notice the units here. How did the units work out? You have a meter per second squared times a second squared. So if I write that out, meter per second squared times a second squared, you'll notice the seconds cancel out. I'm left with meters. So this tells me that that minivan traveled 150 meters. Okay, I'm going to put another question on the board, and I would like you to pause the video after I put it here. Not yet. So let me give you the second question. So here's the second question. I'd like you to read it, and I'd like you to try and do the part where you do the picture knowns and unknowns. So pause this video, go ahead and try to do the picture knowns and unknowns, and then I will put what I got. So this is what I've got so far for a picture. So notice I've set some axes, right? And I said I don't know how fast I'm going at the beginning. I come to a stop, right? I also have a deceleration of 4 meters per second. If you have a deceleration, remember that means your acceleration is pointing against your velocity. So if my velocity is forward, my acceleration is going to point backwards, and it's actually going to be a negative 4 meters per second squared. And I know that this distance here is 65 meters. Alright, so if I do my knowns and unknowns, I'm saying that, okay, I started here, so my x naught, where I started, is 0, and my x is I ended up 65 meters from the starting point. Another way you could do this, by the way, is if you put your y-axis here, you could have said x naught was negative 60 and x was 60, or sorry, x naught was negative 65 and x was 0. But this is how I've done it. This is why it's important that you draw your axes, though. Alright, we're going to say my deceleration, or my acceleration, is negative 4 meters per second squared, and I'm trying to find my initial velocity. Okay. Is there anything else I know? Oh, yeah, there is something else we know, right? I come to a stop. So if I come to a stop, right, that means that my final velocity is 0 meters per second. All right. Now, if we look at the equations, we need to find an equation that has all of these variables in it. X naught, X, A, V naught, and V. But notice, I never wrote down time. So the equation I'm going to use here is the one that I called ain't got no time. So let me just rewrite that. And then the best thing to do, if you can, is to try and simplify this before you plug numbers in. So the way I simplify this is anything that I know is going to be 0, I'm going to say it's going to be 0, right? V is going to be 0, x naught is going to be 0. So I'm left with 0 equals v naught squared plus 2ax. Or if I solve that for v naught squared, v naught squared equals negative 2ax, because I subtracted the 2ax over. Or I could say that v naught is the square root of negative 2ax. Okay, so that's v naught is the square root of negative 2 times negative 4 meters per second squared. Oops, I'm running out of room there. Times 65 meters. Pardon my jumbled work there. But you'll see that my negatives cancel out, right? My negative 2 and my negative 4 cancel out. So I'm left with the square root of 520, which is 22.8 meters per second is v naught. Again, I want to show you how the units worked out, right? See in here I had a meters per second squared times a meter. What's a meter per second squared times a meter? It's meters squared per second squared. But it was all under the radical, so if I take the square root of meters squared per second squared, I'm left with meters per second. Alright. I'm going to do one more practice problem with you. If you feel like you're confident, you can stop the video here. But if you'd like to do one more practice problem, I'm going to do one more practice problem with you. Alright, you are traveling at 24 meters per second on the on-ramp. As you get ready to merge into the interstate, you accelerate over a distance of 50 meters to 46 meters per second. Pardon me. What's your acceleration? Okay, so we're going to start with a picture. So I'm gonna let you do the picture knowns and unknowns by yourself, and pause the video, and when you're ready, go ahead and play it. Alright, this is what I got. Okay, so my v naught is 24, my v is 46, and notice I've drawn where I was at the beginning, where I was at the end. Okay, I start at 0 position, right, because I'm starting at the origin of my axes. I'm ending 50 meters away, so my final x is 50, and I'm looking for acceleration. I guess to be complete, I really should include the acceleration in the video here, or in the picture here. All right, what equation has v naught, v, x naught, x, and a? You should see that the only equation that has those in it is, once again, ain't got no time. The reason I wanted to do this one with you is I want to show you some of the simplification you can do. So again, x naught is 0, so I'm just going to cancel that out. So I've got then v squared equals v naught squared plus 2ax. And I want to solve this for a, right? So let's do the algebra. You don't have to show all these steps, but I'm going to. So I'm going to subtract the v naught squared from both sides. So I've got v squared, minus v naught squared equals, what's left over here? 2ax. And then I've got to divide by my 2 and my x on both sides. So I'm left with v squared minus v naught squared over 2x equals a. Alright, let's try it. So we've got 46 meters per second squared minus 24 meters per second squared divided by 2 times 50 meters equals a. Again, I'm going to check my units first just to make sure it works out. The nice thing about solving these things algebraically is you can see if the units work out. So on the top here, I'm subtracting 2 meters per second, but they're squared. So I've got meters squared per second squared on the top. And on the bottom, I have meters. So what's going to happen? One of these meters is going to cancel out, and I'm going to be left with units that are meters per second squared, which makes sense because that is what acceleration is. So I want to get something into units of meters per second squared. So if I plug in those numbers, I get what? 2,000. That's not right. I screwed that up. 2,000, where's that come from? I need to put parentheses in. I'm getting something like 15.4 meters per second squared. All right. That's how to use the kinematic equations.